Okay, I'm gonna start to present my research. Good afternoon, all audiences. My name is Wirawat Kunakornsawat, and my advisor is Dr. Atipan Pimkhawkam. Today, I would like to present my research, and its title is "The Effect of the Variable Rest Period Training Programs on the Motor Skill Acquisition of the Dynamic Navigation System, a pilot study." In order to ensure that the restorations and implants match aesthetically and functionally with the neighboring and occluding dentition in the anterior maxillary region, implantation has to be done properly. Dental implants must be placed correctly at the proper depth, angulation, and crestal position. This is critical due to the importance of the region, and because if a high lip line is present, the smile line is more noticeable, which increases the consistency of the smile line. Now today, the dynamic navigation system are available for dental implant. The novel of this system was shown to improve the correct 3D position of the implant placement. It uses optical technologies to track the patient and handpiece and to display images onto a monitor. The optical system uses either passive or active tracking arrays. Passive system use tracking arrays that reflect light emitted from the light source back to the stereo cameras. Active system arrays emit light that is tracked by the stereo camera, as you can see at the far left picture. Dynamic navigation systems have many benefits, including high accuracy, the ability to adjust the implant size, device, and position during the surgical process, which saves time and money. It also needs less trauma because the surgeon's posture is better. With less instances of neck and back bending, using dynamic position posture is better. Using the dynamic position helps you to guide the implant placement without relying on the direct visualization in the patient mouth. But to use this system efficiently is not easy, so the clinician must understand that learning curve is required to gain proficiency and they must train. And the question is, which training program result in more rapid skill acquisition in less training time spent? Training schedules have been compared across disciplines, including psychology and neuroscience, in terms of their distributional consequences. Distributed preparation, which combines training with long rest period, is called distributed training. And a long training with short break refer to mass training. Meta-analytic reviews indicate that distributed training is superior to mass training in better retention of the motor skills. Though there is a lack of consensus about when or how long of the resting period of the training schedule affect retention motor ability. So, objective of this study is to evaluate the most efficient training program with variable rest periods to achieve motor skill acquired with the highest level of accuracy in the implant placement using dynamic navigation system. The material and methods. Senior dental students who had no experience with the implant surgery and dynamic navigation system were recruited from the Faculty of Dentistry to Wirawat University. These students were randomly assigned to two groups of 10 subjects each group. Group A training program that lasts many days, and Group B training program that is done in 1 day. Any participant completed the questionnaire consisting of their personal characteristics, consist of age, gender, dominant hand, and educational background. Previous experience such as VR games and musical instruments, and motivation to learn skill for dynamic navigation system. That is motivation of participant, dexterity, and performance prediction. Cone beam computed tomography or CBT scan procedure were taken to for each model with a 3D ICAD machine. The DICOM files from the CBT were uploaded to the dynamic navigation system and entered into its planning system. Single doctor planned each implant position on the CBT scan of dynamic navigation system of the maxillary model. The planning software was used to define the arch and implant dimensional manipulation. Multiple views were used to ideally orient the virtual implant. Virtual plan the 3.3 mm diameter, 10 mm length of the BLT Straumann implant system and optimal position. Before the first training, orientation was given to each participant on the fundamentals of implant placement in order to ensure the basic understanding of the implant placement, how the navigation system works, and how to use the surgical handpieces and drills. The picture shows the training program in both groups. For Group A, participants will be given 3 implantations over 3 consecutive days. So on each day, the participant will place 1 implant. Group B perform 3 implants placement with a single day. The participant in Group B will take a 15-minute break after each session. A 7-day post-training test will be done for both groups by placing 1 implant after the 3rd repetition. Accuracy of the implant position was calculated by measuring the error in the actual implant position relative to the virtual planning position. Implant planning software automatically superimposed to the image data from the post-operative CBT scan onto the virtual planning image. The outcomes were 3D platform deviation, 3D apex deviation, and angular deviation. For the statistical analysis, the independent t-test and Mann-Whitney test were used to determine differences between groups, and the repeated ANOVA test and Friedman-Dunn test were used to determine differences between groups, which 0.05 was the significant level. Oh, sorry. For the result, this table shows the answer of the questionnaire and statistic calculation. Chi-square test show no significant differences in Group A and Group B in questionnaire scores. The result of the accuracy and statistical analysis were summarized in this table. The result of the multivariate analysis of accuracy demonstrated no significant effect of the all parameter between groups. Furthermore, there is no significant differences between groups in both groups. This slide shows the line graphs that indicate the accuracy in 3D platform deviation, 3D apex deviation, and angular deviation, respectively. This study aimed to evaluate the most effective training program in different distributed training schedule using dynamic navigation system by the senior dental student. The important thing is the background knowledge and skill of participants that may affect to our outcomes. So we gave the orientation to all participants or the fundamental of the implant placement, how navigation system work to ensure the basic knowledge. Moreover, we also asked them to fill out the questionnaire about their characteristic, prior experience, and motivation to learn a skill for the dynamic navigation system to estimate motor skill before the experiment starts. Due to the findings of the participant prepared questionnaire score were not statistically relevant, as you can see at the table. So we conclude that participants in the two groups start with the same level of motor skill. In this study, when tested 7 days after the last training, the training program that is done in 1 day had a similar accuracy to the training program that lasts many days. So we can conclude that there is no improvement of the motor skill acquisition of implant placement in both groups, but several studies have shown that significant improvements in motor skills such as both speed and accuracy appear when the measures are taken 24 hours after training, even though no additional training occurred during the intervening time period. So the precise explanation for this is unclear, but the first possible cause of the deviation is a cognitive preventing deviation. Regarding to the navigation system, there is a display that indicates the instrument deviation in real time. The participant will notice the virtual implant position deviating from the plan, and they will automatically change the position to the plan. As a result, the participant will quickly able to reduce the mistakes. The second reason is the measuring the deviation in implant work is a very delicate and small scale task. And it is performed on a millimeter scale. So this is so difficult to even two groups of participants doing the same task with the completely different levels of the motor skill may have no significant statistically difference in their performance. An alternative hypothesis may be that the participants were not sufficiently trained and therefore they were still undergoing in their learning curve. From the study of Karger and colleagues, found that further initiation preparation result in better retention in motor skill. So the limitation of our study is that we focus on only accuracy as a parameter to evaluate motor acquisition from implantation using dynamic navigation system. Not only the accuracy, but also the time is the most important parameter which should be investigated. In addition, we had a small number of the sample size and repetitions of implantation in each group. For the conclusion, from our pilot study, the training program, which lasts many days and is done in 1 day, had no significant effect on the development of motor skills for implant placement in terms of accuracy when the dynamic navigation system was used. Thank you.
Thank you so much, Dr. Wirawat. Is there any question or any comment from the floor? So I will start with my question then. In your questionnaire, you mentioned about the section about the prior experience that you choose 2 items to evaluate, which are the VR game and music instrument. What is the rationale to use this for the questionnaire? For the questionnaire?
Because the dynamic navigation system is like in the we do the implant placement at the real time on the monitor, like it's like a VR games. Then and musical instruments is maybe the part of the motor skill of the hand that we can control the handpiece or drills. And that's we think that it maybe have the effect of the motor skill in the navigation system work.
And so is there any specific type of musical instrument or any kind of
any
musical
kind
instrument.
Musical instrument.
Okay, and as you mentioned that this study is a pilot study.
Yes.
So if you continue to conduct this study from your data, what are you going to do more or adjust for your study?
Okay, I would go to first of all, I would increase the sample size, and second thing is include the time. That is the most important thing that we should measure when we do the motor skill success. And the third thing is the repetition, because we just do the 3 repetition before the post test. I will increase the repetition like 10 or yes, that's something else.
Okay, I see. Thank you so much.
Yeah, thank you.
So is there any question? Dr. Varasini, is there any question in the chat?
No, there's nothing in the chat box.
Okay. Okay, thank you so much, Dr. Wirawat.
Thank you so much. ขอบคุณครับ